What's happening in IP these days that's impacting test?
As we all know, the IPs are getting, on one hand, more complex, and on the other hand, they are shrinking, they are becoming much more miniaturized. And both of these have an impact on test. Right? The impact on the complexity is that the test has to be quite comprehensive and embedded in the IP itself, rather than trying to incorporate the test from the external world on the IP. So incorporating the test in the IP is very important to resolve that complexity matter. In addition, as we are shrinking the dimensions, we're seeing new types of defects. We're seeing new process variation issues. We're seeing a number of manufacturing implications that will require the test to be a lot more comprehensive, and not only comprehensive, but rather tuned properly by the IP provider to make sure that that IP that comes out of manufacturing is of the best quality, is detected properly, is filtered properly, and what comes out of it is safe and it goes to the hands of the customer.
So is it only test, or does test have other implications, particularly in the area of yield?
Yes, test has other implications. Test is the base. Based on that test, you guarantee the quality of the IP on one hand, but also you use the test to do a few other things. You use the test to ensure debugging, to ensure diagnosis of your chip. When the first chips come back, the first silicon, you need to debug that chip. And debugging that chip cannot be done but through the test mechanisms. So the test infrastructure inside the IP that you built and inside the chip that you built will help you do the silicon debugging during that first silicon debug period to ensure that that chip is behaving properly. Of course, the embedded test is not sufficient for that. You also need additional pieces of software that sit outside the chip that communicate with what you have embedded inside the chip. So both together, the external intelligent software as well as what you embedded in terms of test will help you do that debugging properly. That's one. Also, as you mentioned, yield is critical. So again, to ensure the yield, to make sure that you can optimize your yield either through repair, through diagnosis, through reconfiguration, all of that will need the test infrastructure. So test also has implication on yield. So it has implication on debugging on one hand and on yield on the other hand. But yield also will require certain things outside. If I will do statistics on the results, if I'll try to understand what are the different phenomena that are impacting yield, I will need, again, intelligent software outside that can apply certain queries on the data that I collect and help me improve the yield even when I am doing volume manufacturing. Okay? So these two things are very helpful to us. But what does this mean? This means that what we require is not only embedding test infrastructure inside the chip or debug and repair infrastructure inside the chip, but also having the necessary software, necessary external elements that go hand in hand together. Thus, our duty today as IP providers to provide a total solution, to provide a subsystem that goes inside the chip and also has in it the necessary infrastructure outside the chip to handshake with it. Okay? So each IP provider needs to do that. We cannot only give you a block that functions inside the chip. That block has to have with it the embedded test infrastructure and the external support for yield, for debug, and others.
So are the manufacturing steps that are being taken right now, are they sufficient?
Not really. Manufacturing is very important, and what you do in terms of testing to ensure the quality, in terms of debugging, repairing to ensure the yield are very important, but not sufficient. Why? Because we're seeing more things are happening in the field as we're shrinking the technology. As we go to miniaturized levels, we see impacts that come during early stages, during the life cycle, and during the aging period of the semiconductor. That's why during the life cycle of that chip, we need to continue verifying, we need to continue checking and correcting as necessary. So the test and repair that we talked about in manufacturing all along are of course still important but not sufficient. We need to do in the field test and repair. We need to do online checking, verifying, fault tolerance in order to ensure that all these transient errors that are happening, all these soft errors that will come up during the life cycle are taken care of properly.